Today I am working on some basic Python and NumPy exercises. Please watch along if you find it interesting and feel free to work alongside on your computer if you want to practice these codes too. So let's get started. First up, we have to find what is 7 to the power of 4. So the way to do that is we will write 7 raised to the power of 4. For the power we have to use double star here, and that gives us 2401. Next we have to split this string into a list. So we can copy this string here. Let's run this. To split, we can use the split method. Run this and the string will be splitted into a list with 3 elements because the split is at the blank space. If in case you want to split a string at some other point, you can pass in a string here. Let's, for example, we want to split at E. So see what it will give. So it will split at E. So first element would be high space th, then E is splitted, next element is just R before the next E comes in, and then the rest of the string is space Sam exclamation mark. Here we just wanted to split it at the blank space to get the all of the 3 words separately as elements in a list. So it's done here. So given this variable planet and diameter, we have to use dot format to print the following string. So this is a print formatting of the string. What we can do is write print and pass in the string, but we have to use these variables. So at this place, the earth and this number, we want to use dot format here. So what we will do is start writing your string and pass in curly brackets where you want the variable to be. Kilometers. Once this is done, once you have your string with curly brackets in place of variables, we can also pass in temporary variables here. Use dot format method, and here A would be for earth, we have the variable planet, and for B we have the variable diameter here. Now before we do this, we need to run this variables as well. Now if we run this, it will produce the string. The diameter of earth is 742 kilometers. Up next, we have a nested list and we have to use indexing to grab the word hello. So let's run this list here. We have to grab this word hello. This is in a list as its only element. This entire list is third element of this list, which is an element of this list, which is an element of this outside list. So the first element here is 1, 2, then third element is a list which is 3, 4, and then we have this fourth element. So how we can get that list is, this is at index 0, 1, 2, 3. 3 will return this entire list. In this list we have 1, 2, this is the second element, 3 and 4. We have total 4 elements. So this list is the second element at index 1 because indexing starts with 0. So we'll pass in 1, this will return this list, and now we have the third element as this list we want. So it will be 0, 1, 2, indexing 2. So this returns a list with the only element as hello. We want this word hello, so we can index it once more with indexing 0, and this will return us the word hello. So up next, we have this nested dictionary given here and we have to grab the word hello. So if we look at this dictionary, let's run this. If we look at the keys here using the keys method, so there's only one key here, and the value for that key is this list. So let's index the key here first, and that is k1. This will return this list which has 1, 2, 3 and 4 element. Fourth element is this entire dictionary. So our word hello is within this element, the fourth element of this list. So we will index that now, and that will be at index 3 because indexing starts at 0, 0, 1, 2, 3. So this returns this dictionary now. Once again, if you look at this dictionary, there's just one key, and the value of that is this internal list. So we can index it for tricky key that will return this list, and now we have 1, 2, 3, fourth element as the dictionary. Fourth element means 3 index. Now we can once again index it for the key which is target. And then we have our word hello at 0, 1, 2, 3, index 3. So there you go. This was a little tricky, but the way to index a dictionary is using its key value pair. Now next, what is the main difference between a tuple and a list? So the tuple is immutable. What that means is you cannot add more elements to a tuple, you cannot change the existing elements of the tuple or the order of the elements inside a tuple. We use a tuple when we don't want a user to be able to make any changes to the list. List, obviously, as you know, can be changed. New elements can be added to the list, or the existing elements can be changed. Next, we have to create a function that grabs the email website domain from the string in the form user@domain.com. So if we have this email ID, it would return domain.com. So this is the name of the function. So what we have to do to create a function is we have to define the function, we have to name the function and return what we want. So we will start with the keyword def, and then we'll give the name of the function. In this case, we will use this domain get, and then we can pass some parameter here. We will use the string email, and now we have to return something. What we want this function to return is this domain.com. For example, if it was user@gmail.com, then we want this function to return the domain gmail.com or yahoo.com. So what we could do here is, for this string, we can split it at the rate, and then that will return a list with 2 elements. One would be user, the other would be domain.com, and we can return this domain.com, which will be at index 1. It will be second element in the list at index 1 because indexing starts at 0. So we can take this email parameter here, and we can split this at the rate and then index 1. So let's run this function and see if we get our answer. Yes, if you want to see what's happening here, let's see. This is our string. Take this string and use split here with at the rate. So what this returns is a list with 2 elements. First is all of the part of the string which is before at the rate, that is user here, and the second element is all part of the list which is after at the rate, that is domain.com. And then when we index this, for the element at index 1, it returns the domain.com. If you put in the index 0, it will return the first element, which is the user. So this is the same thing. Rather than doing it individually for all of the strings, we have created a function now for all of the strings. If you have a list of say 20 or 50 or 100 strings where you want to get the domain of the email IDs, you can just use this function domain get, pass in all your strings, and then it will simply return the domain of that function. If you have a table in Python, you can create a new column and get the domain of all of the strings there in the table. So this is very useful. Now let's move on to our next question, which is to create a basic function that returns true if the word dog is contained in the input string. Create a basic function that returns true if the word dog is contained in the input string. Don't worry about edge cases like a punctuation being attached to the word dog, but do account for capitalization. So here we have our function find dog. This will be the name of the function, and in the string if there is a word dog, it should return true. So once again we will start with the keyword def, then the name of our function will be find dog. In this case you can give any name which you want to the function, because this function is going to find if the word dog is in that string, we are using the name find dog. Then pass in your parameter. Now you can the thing to note here is you can pass in multiple parameters, and you can also give default values to these parameters. We don't need any default value here, as the string has to be provided for this function, and this will return. The way to check dog is, or check if a particular string is part of another string, is we can use the logical operator in here. For example, if we use dog in param is the parameter which has to be passed, in this case the string that has to be passed for this function. What this function will check is dog in param. This will return true if the dog is in this string. So this function, when we run with a string, will return true. If the dog is not in the string passed through this function, then the function will simply return false. And now we have to account for capitalization as well. So what we could do here is use a method lower, so it will turn the entire string into lowercase. Let's run this, and it gives true. Now again, to check what's happening here is we can take this string and use lower. So see, everything has been turned into lowercase. Now when we check dog in the string, it gives true. Let's say there wasn't a dog, there was a cat here, then it should return false because the string dog is not present in this string. So this is a simple function. To do that, once we have created the function, once again we don't need to write that code individually for each string. We can just pass all of the strings through this code and get our answer. Next is to create a function that counts the number of times the word dogs occur in a string. Again, ignore edge cases. So once again we have to check for the word dog, but now rather than checking if the word dog is in the string, we have to count how many times the word dog is there in the string. So we can start with defining the function. The name of the function will be count dog. Pass in your parameter and then return the function. So here what we can do is take param, turn it into lowercase, and then we can use another method which is count. And whatever you want to count, you can put within this count method as an argument. So we want to count the string dog. Now let's run this and see if it works. It should return 2 because there are 2 dogs here, and yes. So what this is doing is, let's take this string, turn this into lower. The reason we are turning this into lower case is if this dog was, let's say, capital dog, and then if you are counting the string dog in all in the smaller case, then this would not have been counted. But in in the example given for us, it is already in a smaller case, but in some other string could be in it could be capitalized, and in that case it depends. If you want to count all of the word dogs irrespective of whether they are in smaller case or capital case, then you can use the method lower here. If you want to specifically count just the lowercase dogs, then you don't have to turn everything into lowercase. So once we do this, this turns everything into lowercase. See, this t which was capital has been turned into small t. Now we can use the count method, and when you use the word dog, it will return 2. If you want to check for another word, let's say you want to check for faster, it will return 1. We can also include the white space here. Let's say we wanted to check faster space than, it will count that as well. Everything within the string is part of the string and can be checked. If you just want to count the blank spaces, we can count that as well, and it returns 8 blank spaces: 1 2 3 4 5 6 7 8. So next we have to use lambda expressions and filter function to filter out the words from a list that don't start with the letter S. So we have a list here, and we have to filter this to the words that don't start. Okay, so here it says don't start with S, but the example given are the words which starts with S. So let's do for both. Let's run this list. The way to use filter is, we have this filter function here. Inside that, if you check the doc string here, we need to give in two parameters. One is a function which will be implied on the iterable. Iterable is this list on which we want to filter. So for the function, we don't have a ready-made function, so we'll make one. Lambda for word. Let's say what we have to do is, for each of this word is the temporary variable here. For each of this word, it has to check if the first element of that word is equal to S or not. Word, let's say index 0, because this is a string, so we can index this and this if it is equal to string S. So this part will return true or false depending on whether the first letter of each word is S or not. Where it is true, that element from the sequence would be retained, and wherever this lambda function returns false, that word would be dropped. So let's run this, and now we have a filter at this location. If you want to see the list, we need to pass in through the list function, and it returns a list with the word soup and salad where the first letter was S. We can also copy this and turn this for the words which does not start with S. So just turn this double equal to into not equal to, and then it will filter the functions. It will check here the first letter is S, so it will return false, so this word would be dropped. For the next word, it will check this D is not equal to S, so this will return true, this word would be retained. Again, salad would be dropped, cat would be retained, and great would be retained because G is not equal to S. So all of the words which does not start with S have been retained here, and all of the words which starts with S has been retained here. Next, we have a problem here. You are driving a little too fast and a police officer stops you. Write a function to return one of three possible results: no ticket, small ticket, or big ticket. If your speed is 60 or less, the result is no ticket. If the speed is 61 or 80 inclusive, that means it is greater than 60 but less than 81, the result is small ticket. And if the speed is 81 or more, the result is big ticket. Unless it is your birthday, which will be given as a boolean value here. Boolean is true or false. On your birthday, your speed can be 5 higher in all cases. So we have to write a function here to return a big ticket or small ticket or no ticket depending on the speed. We have to use an if else statement here. So we'll remove this pass. The function has already, we have the keyword here defined, and we have named the function, and speed and is birthday are two parameters that will be given here. So speed is the speed at which the driver would be driving, and his birthday is if it is his birthday or not. That would be given as boolean true or false. So what we have to do here, we have to check two things. One is the speed of the driver, and the other is his birthday, because if it is his birthday, he is allowed to drive at 5 kilometers per hour higher than the normal allowed speed limit. So let's account for that first. If we will use an if else statement, if is underscore birthday. So here what this would be checking is if his birthday is true. If it is given as true, it will run this piece of code which we are going to write here. I'm going to create another temporary variable which will be speeding, which will be is equal to speed minus 5. So if it is somebody's birthday, so what we will do is, if it is somebody's birthday, they are allowed to go 5 kilometers per hour higher than normal. So what we would do is, we would subtract 5 from their birthday and take that number as their assumed speed. Else speeding is equal to speed. So if this thing is true, if it is somebody's birthday, then the new speeding would be whatever speed they were going at minus 5. Otherwise, if it's not their birthday, then speeding will be equal to speed. Now we have to use a second if else loop, and this is for printing of the ticket or to return the ticket. So if, let's say, speeding, which is our new temporary variable, if this was greater than 80, because it says if the speed is 81 or more, the result is big ticket. So if it was greater than 80, return big ticket. Next we have a second condition, so we will use elif speeding was greater than 60. So here what this will check first is, if this speeding variable, if it is greater than 80, it will return a big ticket. But if this is not true, then it will check, was the speeding greater than 60, then it will return small ticket. And else, if both of these conditions are not true, it will return no ticket. So what's happening here is, it will check if the speeding is greater than 80. In that case, it will return big ticket and nothing else will happen. The function will stop there. If this condition is not true, then it will check for the next condition, which is if the speeding is greater than 60. So in other words, it will be between 61 and 80, 61 being inclusive. Then it will return small ticket. Otherwise, if that is also not true, that means the speed will be lesser than 60, and so a no ticket would be returned. So let's check if this function works. We have these two function here with the parameter 81 and true. Because it is his birthday, the true speed is 76, so it will return a small ticket. Let's run this, and it returns a small ticket. Again, for if it is not his birthday, then 81 should return a big ticket. And when we ran, we got big ticket. We can check for other speeds as well. Let's say the speed was 64 and it was his birthday, then it should return no ticket, right? No ticket. And then repeat this, got speeding for 64 and false. So it's not his birthday, but he's driving at 64, that will return a small ticket, and it does. So we are fine here. Now next, let's move on to NumPy exercise. So we have to start with importing NumPy first. Import NumPy as NP. Next we have to create an array of 10 zeros. So that's very simple in NumPy. We have a function for zeros which is called zeros, np.zeros, and here you can write in a single number based on how big you want that arrays to be. Here we need an array of 10 zeros, so we'll pass in 10. Let's say we wanted 2 rows here, so we can pass in a tuple 5 comma 2, so it will return 5 rows and 2 column. Let's run this and see. This is a two-dimensional array. We can check that by double bracket here at the beginning and end. And what this returns is two-dimensional array of 5 rows, 1 2 3 4 5, and 2 columns, 1 and 2. But we needed a single 1D array of 10 elements. So this is it. Next we have to create an array of 10 ones. np.ones, and similarly we can pass in the number 10 and it will create an array of 10 ones. Next we have to create an array of 10 fives. So there are two ways of doing it. We just created an array of 10 ones and 10 zeros. We can use both of those here. Let's start with 10 ones, and then what we can do is we need 5. We can multiply it with scalar 5. So this thing created this array and then we multiplied it with scalar, and that 5 got multiplied to each element of the array here. Similarly we can use 10 zeros as well and add 5 to each element of the array. Next is to create an array of the integer from 10 to 50. So the way to do that is to use the arange function. Arange function basically creates a range. If you check the doc string, we have 3 parameters here: start, stop and step size. Start is from where you start, stop is where you want to stop, but this number would be exclusive, so it will stop before that number. And then we have step size. So if you want to jump at particular interval, it will do that. By default it is 1, but if you want to change that, you can pass in a third argument as well. Here we'll pass into a first 2 arguments, which is 10 and 50. So what this does is it creates an array of integers from 10 to 50. But see, if you want to get 50 here, we need to pass in 51. If you pass in 50, it will return only 49. So next is to create an array of all the even integers from 10 to 50. So it's basically the same thing. We will use the arange function from 10 to 50, but this time we need even integers. So we can use the step argument as 2. So it will jump in 2s, it will return 10, then 12, then 14, then 16, and so on. Here you go. Once again, if you need 50, we need to go till 51. So next, we have to create a 3 by 3 matrix with values ranging from 0 to 8. So how we can do this is, we can use the arange function. The values have to go from 0 to 8, so we can pass in 0 to 9. 9 would be exclusive, and this will create an array, one-dimensional array of 9 elements ranging from 0 to 8. Now we can reshape this. Using the reshape method, we can pass in 3 by 3 here, and this will reshape this array into a two-dimensional array of 3 rows and 3 columns. Next, we have to create a 3 by 3 identity matrix. We can use the I function there, and an identity matrix is basically a matrix, square matrix, which has equal numbers of rows and columns, and all the diagonal elements are 1 and all of the off diagonal elements are 0. So we can just pass in a single parameter here, which is 3. This will be the number of rows as well as the number of columns, and all the diagonal elements would be 1 and the other elements should be 0. Next, we have to use NumPy to generate a random number between 0 and 1. So we can use it using the random function. Start typing rand, press tab, and here we have different options. We will use the rand function, and because this is between 0 and 1, so rand returns, if you check the doc string, it creates an array of the given shape and populate it with random samples from uniform distribution, that is 0 and 1. So all numbers generated would be between 0 and 1. And see, if we don't pass in anything, by default it would be 1 and it will create a single number between 0 and 1. However, if you pass the argument as 1, it will create an array of 1 element. So it depends what you are looking to generate. If you just want a single random number between 0 and 1, you can pass in, you can run this without passing an argument, or if you want an array, you can pass in 1 here. You can pass in multiple, you can pass in any number based on however random numbers you need. If you want a two-dimensional array, you can pass in a tuple here as well. Here we just want a single random number. Next is to use NumPy to generate an array of 25 random numbers sampled from a standard normal distribution. So standard normal distribution is different from uniform distributions. In a standard normal distribution, we have a bell-shaped curve with the highest point of the curve, the peak of the curve is at mean 0 and the variance is 1 for the standard normal distribution. So mean at 0 and variance is 1. So about 66% of the data in that curve will fall between minus sigma and plus sigma. Within 2 sigma, minus sigma to plus sigma will have 66% of data. About 94-95% of data would lie between 4 sigmas, minus 2 sigma to plus 2 sigma, and the 6 sigmas, that is minus 3 sigma to plus 3 sigma, will contain about 99% of the data. So for this one, we can use the random function, and we have rand and for normal distribution curve, and we need 25 random numbers, so we'll pass in 25 here. It will create an array of 25 random numbers. Most of these numbers would be closer to 0. It will be both positive and negative, as the normal distribution curve has mean of 0. Next, we have to create this following matrix. So if you take a look at this matrix, this is a two-dimensional array, as we see double bracket at the beginning and end, and it starts from point 0, 1 and goes up to 1. So there are a couple of ways we can do this. Let's do using a range function. We will start with 1 and it will go up to 1, 0, 1. So remember, this stop is exclusive, so it will go from 1 to 100, and then we can reshape this into a 10 by 10 matrix. And what this will do is it will produce this matrix, and because it is 0.01, we can divide it with scalar 100, so it will produce that matrix. There's another way we can do this using linspace. What linspace does is it returns evenly spaced numbers over a specified interval. So if you check this matrix, all of these, the space between each element is 0.01. So we can start with 0.01, we can end with 1, and in linspace this is inclusive, this is not exclusive, and we need 100, exactly 100 elements here. So this will produce this array, and then we can reshape this into a two-dimensional array using 10 by 10 tuple. So it produces the same result here as well. Now next, we have to create an array of 20 linearly spaced points between 0 and 1. So we'll use the linspace function here. It's between 0 and 1, and we need 20 equally spaced points. So if you subtract any two consecutive elements here, you will get the same a result which should be 0.05263158. Next we have a matrix given here, and we will index and select part of this given matrix. So let's run this, and now we have to write a code here that reproduces the output of the below cell. We have to reproduce this. Be careful not to run the cell below, otherwise you won't be able to see the output anymore. Yeah, so we have our mat here. We have to produce this array. So it's from here 12, 13, 14, 15 and the next two rows. So we have our, for indexing what we will do is we'll first pass in rows and then comma columns. So this is 0, 1, 2, 3, 4. So starting with index 2, return all the rows. What this colon means is starting from 2, go to 3, 4, 5, where we will stop it. Let's for example, if we pass in 5 here, or if we pass in 4 here, 4 would be exclusive, so it will return the row second. Second is as in the index 2, then index 3 and then index 4, but 4 would be exclusive. So what this will return is just this two rows. Let's check this. Yeah, now what I want here is, here we need all three rows starting from 2 all the way to the end, all of the rows, and then starting with this second column I want all of the columns as well. So 1 colon, and this will return this array here. Next we want the element 20. So this 20 is here. This is 1, 2, 3, 4th row. That means index 3. Here because we need a single row and a single column, we won't use the colon here. Colon is used to select multiple rows and multiple columns. We have a single row which is at index 3, and then we have a single column which is the fifth column, index 4, 0, 1, 2, 3, 4. So just pass in this and it will return the item 20. Next we have to return this array 2, 7, 12, which is here 2, 7, 12. So for the rows we have first three rows starting from 0. We don't need to specify, this means from the beginning. If we don't write 0 here, or if you write 0, it's the same thing. We want the first row, second row, third row, so we'll pass in index 3, because remember indexing starts from 0, so it will return 0, 1, 2, but it won't return 3. This is exclusive, and we don't need to write 0 here. Just the colon means starting from the beginning, and we only need one column here. So see, if I put in just the index of that column, which is 1, it returns a one-dimensional array of just those values which we were looking for. If you want a two-dimensional array like this, we can use this colon symbol and pass 2. 2, remember, is exclusive, it won't be inclusive, but it will return a two-dimensional array of those elements. Now we need this array which is just this last row here. There are a couple of ways of doing it. This is row number 5, which is at 4, index 4, so we can pass in a single argument here, and this will return this one-dimensional array of this last row. There's another way of doing this. If you know for sure that you need the last row, you need this to return the last row, we can use -1 indexing as well. -1 means it begins from the endpoint last, so it will return the same thing. And for this one we can simply, we need last two rows. So one way of doing this is you can start with indexing 3, 0, 1, 2, and this is 3. So beginning from 3 everything, this will return these two rows with two-dimensional array. However, we can also use -1 to -3. Now that doesn't work. Oh, so this is the way of doing it. If you want, oh, so if you want just the second last row, you can put in -2. But if you use index, it will be from second last row all the way through. But it's better to use it this way, just in case a new row is added to this array, and then it won't be the last row and won't give the same uh, row, it won't return the same row. So it's better to use it in the conventional fashion. Now next we have to find the sum of all values in mat. We had our mat matrix, we have to find sum. You can use the sum method here and it will return 325. This is the sum of all elements. If you want to find standard deviation, we can just pass in std, and if you want to check other methods here, you can just write dot and press tab, and it will return all of the available methods here. You can select any method and then check the docstring uh, about that method, and it will explain you what that method does and what arguments you have to pass in. Now next we have to find the sum of all columns in mat. We will use the sum method, and now if you check the docstring, you will notice we have an argument for axis here, and the sum actually returns the sum of the array elements over the given axis. So there are two axes, 0 and 1. 0 is for row, 1 is for columns. So if we sum it across the axis 0, that means across the rows, it will return the sum of all columns here. And if we sum it across axis 1, this means across the columns, so it will return the sum of all rows. And we have those that one dimensional array here. These are the sum of all rows. These are the sum of all columns. So that's all for this video. Until next time, see ya. Thanks for watching.